Well, here's an extension to 2.4.4 when we're talking about the squares. I did kind of briefly go through because we don't typically test this challenging, and I very rarely have math majors in my math class. It makes me sad, but I've had someone that's expressed interest, so this is more of a more in-depth one. So if you're like I'm barely hanging on as is, just with the delta epsilon and everything else, maybe you want to jump past this one. But if you want to get into depth with it, your future math major, maybe you plan to go to grad school in economics. I actually had that plan and found out that I got stuck in higher level math classes, so you'd need to know this as well. But if you're an engineer, physicist, thing like that, this really does not apply to you. And I don't test to this level, so you don't need to stress too much about this. But if you're interested, I'm gonna do my best to try and explain it. Now, I'm not the most precise person in the whole freaking world when it comes to this. There's better mathematicians out there. Pretty much anybody that's called a mathematician is probably better at it than me. But I feel like I can sometimes kind of explain stuff. So if you want real precision, go look up some PhDs and stuff. If you want kind of what's happening, maybe I'll be helpful. So I have written out already, just for the general, and then what it is for all epsilon greater than 0, there exists a delta greater than 0, such that the difference between our x and our a values, if it gets when the difference between them is less than some delta. That's going to imply that we can keep our function value, the difference between that and the limit, less than some other small number. So basically saying if you can get your x values really close to some value of a, we can get the y values really close to the limit. All right, lots of stuff written there. But our job is to be able to read it. Actually, like, do you see how like I'm reading it and I'm saying that like the difference of x and a. Do you know the x minus a inside of an absolute value? That's just like the difference. Like, what's the difference between 4 and 7? Don't think negative or positive. You're just like 3. What's the difference between 12 and 100? 88. So just the difference between, because we're taking the absolute value. We're trying to make the difference really freaking small. Yeah. All right. Go away. I knew that was going to happen. Okay, moving on. All right, so we're going to set ours up. Sorry. So we go... 0 less than x minus 1. All right, less than delta. That's going to apply. So the difference between x and 1 is our x is getting, we can make it real small. We get real close to 1 with our x values, then it's saying that we can find that our function is going to get really close to that limit, some other real small epsilon. So there's our first step telling us what to do. We no longer need to look at our proof up there, or the idea. We can start to run now. So, bang, let's go find delta. And here's where all the weird's going to happen. And it's going to be once we start choosing that minimum game. Yeah. So let's set it up. And we're going to say, all right. So, oh, shoot. I wrote f of x in there. I wrote the general term. It's x squared plus 1 minus 2. My bad. Sorry about that. Moving on. So now when we go to take our x squared plus 1 minus 2, which is less than epsilon, we move into it and we break it down. We get x squared minus 1 is less than epsilon. And then I assume you kind of know what's happening here. And then we broke it up like this. All right. Now the weird. Because we have two things being multiplied together here, two functions, and we don't want our epsilon in terms of an x. I've seen proofs online that do that. I don't know. That's not the way I was taught. I was taught to keep the x's the heck up out of there when you're talking about your epsilons and your deltas. So you might see some proofs out there that include the x's. Yeesh, I don't like that shit. I really don't. I think that's bad form, but it's kind of showing you what's happening. And it's kind of being lazy how I quickly went through your problem and didn't explain everything. I was being lazy. I'll do my best to be a little less lazy about this. So once we have two factors that they don't match, these are two different things, we have to play new games. We need to play something new. Now, we're going to, just for the sake of how this works well, somebody back in the day just went, you know what? Just do this. Take your absolute value of x minus 1 and set it less than 1. So take this piece and just claim that it's less than 1. That this is going to work. Because in essence, what you're saying is your delta is equal to 1. That's what you're kind of setting it up. But we're gonna wait on that for just a moment, because if you've watched this already, we're gonna dick around with this thing, and it's gonna look a little bit different. And then we're gonna choose a value that's gonna cover our ass and make certain that we get the right answer. Okay? So we're choosing it to be 1, and the reason we choose 1, do you know why the reason? Because it's the easiest frickin' number we can think of. It can't be 0, because 0 is the easiest number. That's the easiest frickin' number. We chose 1, we could choose this. It makes no frickin' difference. We could choose 15 if you want. You're just gonna make your life harder. It's just a worse number. 1 is the simplest thing we can come up with. It's just some random ass number that we're gonna go with. Alright, pushing forward. Now our next step in the manipulation is we want to take what's in green right here, and we want to manipulate it to make it look like this, so we can get rid of it. So we can just turn that into a number. We're going to play a game where we can cover our ass 100% to make sure that we're going to keep this shit less than epsilon. Like a lot of the numbers we come up with, we could just choose much bigger things. Like in the past, we might have had an epsilon over 4 was our answer. Well, epsilon over 40 would work even better. All right. So these aren't precise. These are just showing us games with less thans. I don't know if I'm even making any sense. Okay. So we're going to take our absolute value of x minus 1, and we want to manipulate it and take this absolute value of x minus 1 and put it through some function thing and make it look like the other one, the x plus 1's absolute value. Really precise, huh? So we take our x minus 1 that is less than the absolute value, less than 1, and we say it's negative 1 is less than x minus 1. Ooh, shit, not that. Not that. Less than 1. That's the definition of the absolute value, right? Because of the interior, it's got to be greater than negative 1, and it's got to be less than 1. Now we want to make this x minus 1, look like x plus 1. So what do we need to add to minus 1 to make it plus 1? That's right, we have to add 2. So we'll add 2 to all three, for lack of a better word, sides. And we end up with 1 is less than the absolute value of x, or not the absolute value, just x plus 1 is less than 3. Now let's explain why we choose this 3. And why don't we choose the 1? Well, the x plus 1 is greater than this positive 1 that's right here. So hold up. When we're talking absolute values, wait, like this isn't even going to turn into this. The absolute value of x plus 1 less than 1, but we want that shit greater than 1. Huh. I don't think that's a good choice. Look, it's already set up for us. We could take something and to cover our ass, go, you know what, let's ignore the back end of this, the smaller number. And what if it was actually like this? We made a bigger interval. We're like, let's just choose a bigger frickin' interval. And now we can say x plus 1 is less than 3. What this does, now I know this is a ton, it's so hard on the brain, and we're trying to understand this is one of the most challenging concepts. We're just trying to make sure that if we're going to replace in something, we have to make sure that this number, we're like, dude, if we put this shit in, we have to make sure that if we put that number that x plus 1 is actually going to be smaller than this. We just wanted to choose a number that's big enough, just large enough to cover our ass. Just to cover our ass to make sure that we're going to guarantee that this shit's still going to be less than epsilon. So we're like, well, you know what? Let's go worst case scenario, and let's take it all the way out to 3. And that's why we're going to replace it right in here with a 3. Let's just cover our ass. Let's make this thing as big as possible just to make sure. Because as I'm calling this number as big as possible, when we divide it over, a bigger number on the bottom actually is saying that epsilon over 3, that's actually saying that's a smaller number. We're actually asking our x minus 1 to be even tighter. So if we would have chose a 1 here instead, so back here where I got rid of it and I said pretend it's supposed to be like this. If we would have chosen within an interval of 1, epsilon over 1 is a much larger number than epsilon over 3. It's 3 times freaking larger. So we actually said we want the difference between our x and that limiting a value. We want that to be even freaking closer because we want to guarantee that we're going to be within that epsilon. We're just tightening up the range. We're just being more of sticklers for it. Bullshit, we just found another damn epsilon, or we just found another delta. That's a problem. We already found one from up here. Because that's usually the game. We want to get down to this and go, oh shoot, but now we have 2. What do we do? Well, we're going to write in that we have that our delta is going to be equal to the minimum of 1 and epsilon over 3. Now there's a logic to why this is going to occur, so let's go on a little journey. Let's just look here. What does this mean for delta to equal the minimum of 1 and epsilon over 3? And what this means is delta is going to be less than or equal to 1 and delta is going to be less than or equal to epsilon over 3. If delta is equal to the minimum, so it's equal to one of them. So one of these is just an equal sign. But if it's equal to the minimum, so let's say, for example, possibly, if delta was actually equal to 1, then 1 must be smaller than epsilon over 3. Therefore, since 1 is smaller than epsilon over 3, and your delta is equal to 1, that would be true. Or vice versa. What if epsilon over 3 was the smaller of the two? Then we would say that delta was equal to epsilon over 3, because that's the smaller of the two. And since that's the smaller of the two, epsilon over 3, right? That's less than 1. It's the smaller of 2. But that's delta is less than 1. And that's why we have that both of them are less than or equal to those values. So we would say that delta is both less than or equal to 1 and delta is less than or equal to epsilon over 3. Let's return to the proof part because we've just found our delta and that was the whole point. So let's go to kind of the proof. This isn't really a proof that I show you at all. I'm not really doing any proof writing, but we're going to take our f of x, which was x squared plus 1, minus our limit, which was 2, and we say less than epsilon. But we don't want to write the less than epsilon. We're going to do a little progression here. We're going to work our way down. And we know that this ended up becoming x plus 1 and the absolute value times that x minus 1. And we had said before, it's like, hey, didn't we say let's keep the absolute value of x plus 1 less than 3? Just to play it safe. So let's say that this is less than 3 times the absolute value of x minus 1. So just taking care of business, like making sure, just get a bigger ass number there. We're making sure that we're okay. Now, here comes the next step, is where we need to use a less than or equal to sign. And we're using that from this purpose from back up here, because we're not 100% certain. We're not 100% certain whether this is truly the value of the delta we're going to choose. We're not certain if that's going to work. So we're like, let's just roll it through and let's just see what happens. So we say it's less than or equal to, and what the hell, let's just pop it in, that epsilon over 3, and oh my word. Oh my word. We just showed that this is less than epsilon. Right? Look at the less than symbol. We had to hit it. And then we went less than or equal. We went in it just a little bit further. It could have even been an equal sign, but we would have been fine. So it turned out that we handled business and just proved it. Now we get to go, wow. Therefore, the limit as x tends towards 1 of x squared plus 1 is equal to 2. Do a little box or whatever your thing is. People make cats and do all kinds of other random shit for their proof symbols. yeah, so there's kind of the game. Hopefully it made it a little better for you. Maybe it left something out. Maybe you still feel unsatisfied. Go watch a real mathematician do this shit, not me. So hopefully it helped. All right, see you.